every student's favorite part of science class is defining experimental variables, right? I mean, who doesn't love independent, dependent, and control variables? Well, let's try to demystify them a little bit today, so maybe you hate them a little bit less. The independent variable is the experimental thing that you are changing on purpose in the experiment. Consider it kind of your input. And the dependent variable is the thing that you are measuring, that you are hoping changes in response to what you did in the independent variable. Consider it kind of like your output. After you decide your independent and dependent variables, everything else that could possibly influence the outcome of that experiment has to be controlled or kept the same so that we can be sure that the cause and effect relationship between the independent and the dependent variable that we're trying to establish is not interfered with or messed with by any of those other controlled variables. So we want to rule out as many possible things that could be affecting the outcome as possible. If I wanted to design an experiment to try to figure out what my dog's favorite treat was, then I need to figure out what I'm going to change in my experiment. And I would use different treats because that's what I'm trying to figure out, right? What I'm looking for is some sort of measurable effect in his behavior in order to determine which treat is his favorite. So I'm going to go with which treat he chooses first if I lay them all out in front of him. Then I have to decide about all of the things that could possibly influence his choice and try to keep them as much the same as possible, like the size of the treat, the location of the treat, who is giving him the treat, so that those things don't interfere with the cause and effect relationship of which treat that he prefers. If I wanted to know how the stir rate affects how something dissolves, then I'm going to change the stir rate like fast and slow, and I'm going to measure how long it takes for something to dissolve in that substance. Things that I want to keep the same, I don't want to be using different substances like, salt slow and sugar fast. I want to make sure that the amount of the substance and the amount of the solvent are kept the same, and the temperature is the same as well. Because the goal here, right, is to establish cause and effect if the stir rate really affects the time to dissolve. Does the flavor of toothpaste affect how often my kids brush their teeth? Well, I would use different toothpaste flavors, and then I would want to measure somehow how their behavior changes, which would be how often they brush their teeth, how many times per day. I'd want to keep the same toothbrush, the same prompts for me, the same reward systems, because I want to know that the reason that their behavior is changing is because of the flavor of the preferred toothpaste. So finally, for our video lab, if we're trying to figure out how the temperature affects the solubility of a substance, the thing that we're going to change on purpose is the temperature of the water, cold, medium, and hot water. Then we're hoping to see that it's going to have an effect on the amount of the substance that is dissolved. Then we need to control anything that would affect how much is dissolved, which in this case would be the amount of water. We want to keep the same amount of water for all these tests so that we know that the amount of water isn't causing more or less to be dissolved. It's the temperature that is causing a change in the amount that is dissolved.